Hi, my name is Julia Dye, and I'll be talking about my project, which used machine learning and image classification. This past summer, I worked on a program that could recognize the letters of the alphabet in American Sign Language. In this presentation, I'll go over the three main steps of the process, from training to data manipulation to continued training. American Sign Language, abbreviated as ASL, is a language that the deaf community uses to communicate in the United States. ASL uses hand, torso, arm, and face movements to express the English language. Whereas most words in ASL require movements, the letters of the alphabet are composed of still signs, making it possible to classify images of them. The first big step is training the neural network to recognize the different types of letters. I use a convolutional neural network, which is a powerful type of neural network usually used to analyze images. They often consist of many layers that pass filters over the image to track features. Convolutional neural networks are incredibly cool, but it can take a long time to build a network from scratch. Instead, we can use transfer learning to speed up and optimize the process. Transfer learning is using a model that was built and trained on a different dataset to solve a similar problem. One example of a commonly used model is VGG16, which was pre-trained on the ImageNet dataset, which means it can classify 1,000 different types of objects. We can keep this model's architecture and weights, fine-tune it to be more specific to our task, and then train this model on our own dataset. The resulting accuracy is much higher than training a model from scratch. I spent a majority of my time training different types of models and fine-tuning them to try to find the optimal model. These were the three main ones I tested. If you look at the chart, you can see that the validation accuracy for all three is pretty good. However, I wanted to test the model on my own images as well, so I compiled a total of 116 images to see how well the model could recognize these. But as you can see, the resulting accuracy was much lower for this. After analyzing the original dataset, I discovered a big problem. These are the sample images from the original dataset, and these are the images that I took on my computer. As you can see, all the pictures in the original dataset were taken in front of the same white background, whereas my pictures have a lot of other objects in the background as well, which accounts for the large difference in accuracy. To address this problem, I decided to create my own dataset of images. To do this, I started by taking 100 images of each letter. I tried to do them in front of different backgrounds. Then, I used data augmentation to increase the size of the dataset. Data augmentation means slightly altering images that you already have to create more data. For example, I changed the color saturation of the pictures I took to create a total of 45,000 images. Lastly, I split my data into training and validation and added them to the original data. After all of this, I had a new dataset that contained 124,700 images total for my model to train on. The only thing left to do was retrain the model using this data. I decided to use the ResNet 152 model because it yielded the highest accuracy with the original dataset. After training for about 24 hours over the course of 20 epochs, the model was able to recognize 100% of the images in the test dataset I previously created, as you can see in the confusion matrix. I then tested the model on a completely new batch of images that I thought it might have trouble identifying due to excessive background noise or bad lighting. The model was able to correctly identify all the images, which was very exciting to see. Thus far, I have only been working on image classification and making this model as accurate as possible. But machine learning is an incredibly useful field, and there are steps that I can take to improve my program as well as apply it to real-world situations. One big step would be applying the model for live video recognition. It would be able to tell you what letter you were making as you did it in real time. Another step would be applying similar principles of machine learning to analyze videos and determine what words are being signed. Thanks to my managers, Jin Lee and Hongzhi Lee, for all their help and mentorship throughout the course of this internship, and thanks to Microsoft for giving me the opportunity to work here.